Wait a second, just I will make.
Ma'am, was there any session yesterday?
I think so. Yes, it might be. Why? I haven't asked the other TA, but why the session was not there yesterday?
Ma'am, probability session, was that?
Yes. I think it was there yesterday. Actually, the other TA teaches on Friday and I teach on Saturday.
Okay, ma'am.
Yes. So my screen is visible.
Yes, ma'am.
Okay, so we have covered the basic conditional probability and Bayes theorem and all. So today we'll start with the random variables and this distributions of the random variables basically. So before starting, I think last time there was like the students were saying that we want to do the assignments which are already solved. So I have solved the assignment 0 and assignment 0 only actually. So I think we can first solve assignment 1 and assignment 2. Then we can move towards the other part. Is it fine, or you want that we should move to the like the teach like learning part and then we'll solve the assignments? Can someone tell me like should I solve the assignments first, or first we can learn the basic things of the random variable? We can cover that topics: continuous random variable, discrete random variable, then we can go to the assignments.
Ma'am, we should study the theory first.
Okay. So we'll at the end, like when last 30 minutes, we can solve the assignments. Is it fine? So now, first of all, I want to also ask you that is there any doubt like in the last classes? Bayes theorem, conditional probability, is it all clear? Like, are there enough examples? If there is any doubt, like we can go through that again and we can solve like in any question which I have solved or some other question, you can mail me as I have told you. Okay, yes, clear. Okay. So let's move to the random variable. So basically, as per the definition, I can say that random variable is a function belonging to real number. So if we are talking about any event, x is equal to a random variable x, basically for x belonging to R. That is what we are calling as a random variable. And we are first of all considering, suppose if they are in countable range, any random variables are in the countable range, we call it as discrete random variable. So now coming to, actually, I want you to first of all like be clear with the random variables expectation and the distribution factors like discrete random variables and continuous random variable. For that, I want that many of the examples, how the mean, variance also, I think variance is not covered in the class, to be very clear with that. So let's go through the example first. Okay, this is already solved in the class only. So I'll go through the same example to check that is it clear to you. In a class, we ask the students, then we'll go through the other examples and all, their birth dates one by one. and continue till date repeats. Assuming that 365 dates are there, basically leap year is not considered. So how to solve this? Can someone give me the intuition behind it? Come on. I am in a class. We are asking the students what are their birth dates one by one and continuing till the date repeats. Okay, I'll go through it and then we'll solve together. So suppose X is a random variable, or I can say the number of students asked. Now, what is the probability that X is equal to K? This is basically given to us that our birth dates are in a class, students, we are asking the student their birth dates and continuing that, and X is the number of the students, and what is the probability that X is equal to K? Was this example clear to you? Can someone tell, or what is the intuition or something? Yes. Yes, yes.
Ma'am, the date repeats in kth, by the kth student. So ma'am, till k minus 1, we have distinct dates. So ma'am, we multiply their probabilities, like 365 by 365, then 365 by 364 by 365, and so on till k minus 1.
So now what we are saying is, as you have already said, that first of all, the first student can choose any of that. Suppose 365 probabilities. Now, the second one should have the distinct date, which is not taken by the first one. That is, one is taken. So how many are left? I can say 364 dates and so on. And then 365 minus K minus 2 over 365. What is this? Can someone tell me what is this? You have told me correctly. What is this I'm writing? Like when we see it first time, it's like, what is it written? Like K minus 2, how is it coming? I'll write. What is this?
Is the student number we are asking. K minus 2th student we are asking.
This is K minus 2th student. Are you sure?
Yes, ma'am.
This is first. Okay. For the second student, I said that the first student, it shouldn't match with the first student. Now, for K minus 1 student, K minus 1 student, what I should say, that can I say it shouldn't match with K minus 2 earlier dates? Am I correct?
Yes, ma'am. Yes, ma'am.
So it is not K minus 2th student, it is K minus 1th student. What I'm saying is the K minus 1th student shouldn't have the date which were earlier taken by K minus 2 students, which were earlier, like this is suppose 10th student. 10th student shouldn't have the date which is taken by all the other nine students. And then the other, what is the other question? Like, what is the probability X is equal to K? Now, K is basically taking the K minus 1 should be distinct and Kth is repeating. That is what we are saying. Till K minus 1, they shouldn't repeat. K is repeating. So if K is repeating, we can take any of dates from K minus 1 we have taken. If 11th is repeating, then we can take any of the date from these 10 basically. That is what it is saying. Any doubt till now? So basically we can simplify it as 1 minus, okay, it's fine only. So this was the main intuition that I want to tell you. I was aware that there may be some doubts in this. So, and here it's like paradox when we have in the smaller number of Ks only, we'll have the repetition as well. That is the paradox. Any doubt in this equation?
No, ma'am.
Okay, let's proceed forward. So independent random variable. If I'll say that X and Y random variables are independent, I can say that P of X is equal to X multiplied by P of, we have seen the independence before also, I think, in the classes. Then the example in the, I'll again have the same example that was given in the class itself. X is equal to 1. If a dice thrown and we get basically the even number, otherwise it's equal to 0. And suppose the other random variable y is 1. If dice thrown and we get the prime number, otherwise it's 0. So by intuition, what can you say that these are independent or not? I'm not talking about solving them. I'll just go by the intuition based. What do you think, that they are independent or they are dependent?
Independent.
Independent.
Are you sure?
Yes, ma'am.
Okay. Uh, as you have said, they are independent. What if I say that, okay, let's go through that, whether they are independent or not. Can I say, if I say that, if a number is even, then almost it's not prime, mostly?
Yes,
Ma'am,
ma'am.
but the probability of getting even does not affect the probability of getting prime. So hence it is independent right now.
The probability of getting even, you are saying, does not affect the probability of getting prime. What others think, okay, he has given the statement that the probability of getting an even doesn't affect the probability of getting prime. What are the others views about this?
Ma'am, it seems they affect each other, but when we do the calculation, ma'am, they don't.
Yes, can you repeat?
Ma'am, it seems that they affect each other, but when we do the calculation, ma'am, they don't affect.
Okay, you are saying it may intuitively they are dependent, but when we do the multiplication, then
Yes, ma'am.
okay, can you tell me then what is the probability of X is equal to 1?
It's
Let's,
half.
1/6.
it is half. And what is the probability of Y is equal to 1?
It's also half.
Also, no.
It is also, it is half. Y is equal
Yes.
to 1 means that is prime. That means
So
2, 3.
it is 2, 3, and 5. Yes.
Yes. So it is also half. And now when we multiply it, then what we'll get?
1/4.
Okay. Now, if I say that, what is the intersection of them?
At point 2,
1/6.
1/6. Now, is it equal or it is not equal?
Not equal.
Not equal. So whether they are independent or they are not,
They're dependent.
they are dependent. Now, can you go through the intuitive thing? Actually, I think in class they have written 1 also as prime. It shouldn't be. Am I correct? Like, have you seen any of you have seen the lectures?
Yes, ma'am. It's written.
Yes, yes. Okay. So now you always saying it's independent, but we are saying that no, it's dependent. And you were saying it's looking like dependent when we multiply, we'll get the same. If a number, if I'll throw the dice and if it's even, then I can say that it's not prime unless or until it's not 2. So we can say that they are dependent and like anti-correlated, I can say. Now coming to expectation. Should I proceed forward? Any doubts? So if I talk about expectation, can I say it's just, I can say average of the possibilities weighted by the probability, or I can say likelihood. Again, this, I don't want to give you this statement only. We'll go through it, how the expectation, basically the sum into P of X is equal to X into X. That is what it is expectation, how we find it basically. Now again, a class example only I'm going to take. Your friend gave rupees 100. If prime turns up in dice, how much should you pay in opposite case? So what we are saying, that suppose there is a prime number, and if prime is coming, then we are saying that basically then your friend will give rupees 100 rupees, and if the prime number is not coming, then you will give, but how much you should pay, so that there should be like it should be, the expectation should be 0. I mean to say that no one should get benefit. It should be equal, like you and your friend are getting equal weightage. You are in both same stage. It shouldn't be one is benefited over other. That is the case. If I say that what is sample space, that is 6. What is the probability that okay, what is the sample space that the prime number will come? 2, 3, 5.
2, 3.
So take like this. So 100. If I'll write simply, if your friends win and otherwise X. Now we want to determine what is X. We know the expectation. We are saying that what is the probability of X is equal to 100. We know that how to calculate it. Multiplied by 100. We want that expectation so it be 0, so that there should be an equal chance, or I can say it should be equal, or the subtraction between them. I mean to say that should be 0, or I can say this is equal. What is the probability that X is equal to 100? I can say
Half.
half into 100. I can take it this side. And what is this? Again, half?
Half.
Hmm. Okay, I can take like this only. 100 minus x. I can say the same. But in the class, actually, they have considered here 1 also. Sorry, I think this. So that is why the results are different. So it is an equal share only in our case, basically. Is it fine? If your friend gives 100 rupees for the prime turns up, and similarly, you will also give 100 rupees if prime doesn't turns up. Suppose here we are taking, actually it shouldn't, there is some bug here. Can you tell me like some flaw is here? Is it half? Is it really half? Something we have done incorrectly. What do you think?
1 is not a prime number.
And 1 is not a composite as well. So how much?
It's 2 by 6, which is 1 by 3.
1 by 3. So whatever the x will get, that is the basically the value. But actually again, the probabilities are here not adding up to 1. Okay, let's not worry about that. So this is how we'll calculate here, how much we should give. So how much will be x? 150?
150.
So I can say that if your friend wins, then 100 rupees, and if you wins, then you have to give 150. Like if you win, then your friend have to give 100 rupees, and if he wins, then you have to give 150 rupees. Is it fine now?
Ma'am, the question it is not mentioned, ma'am, that it should be composite or not.
It's okay, okay. Then again, you are correct here. In the question, it is not mentioned that it is composite. Okay, if I mention here composite, then it's 150. And if I mention opposite, then it's 100. Nice. Clear? Now, is it correct now? Nice observation. Now coming to variance, though it's not covered in the class, but this is also as important as that. So variance of x, basically,
Ma'am?
Yes.
Ma'am, it is covered in the later classes.
Okay. I haven't seen the later, the next lectures. Okay, so we'll cover it now. Is it fine if I'll go? Because what I was thinking, I'll go through like Bernoulli, then Bernoulli expectation and variance. We'll try to compute, then binomial variance and expectation. I'll try to compute rather than coming again. Is it fine if we cover now only?
Yes, ma'am.
Yes.
No problem.
So that a flow shouldn't be broken up. Like we should go like this only. I thought that they haven't covered because I saw these video lectures only of this week. So I was like, they are only covering. And what about if you have seen the video lectures of the next week? So this Poisson and this uniform random variable, Poisson random variable, they have covered that also or not?
Yes,
Have
ma'am,
you
they
seen?
covered.
They have covered. Okay. Then I'll that things I'll leave up to next week, but variance I'll cover now only, so that the flow shouldn't be broken, and it should be like we should go through each distribution and then compute its variance and mean basically. So variance, can someone tell me what is it? How far is a random variable from its mean? The expectation of that, can I say? X minus expectation of X is how far a variable is away from the mean. That is basically how we capture what is the variance. Is it correct? So if I have some mean and it is scattered, how much in layman language, rather than going to mathematics, in layman language, I can simply say that how much it can be scattered away from the mean, basically. That is, we call it as variance here. If I say about y is equal to ax plus b, and if I want to calculate the expectation of y, how I'll calculate? Sum, as we know, the expectation is sum into the probability. Now, what will I do? I'll open the brackets. Okay, one more thing. First of all, I should tell you that, then I'll come to this. Linearity of expectation.
Ma'am, we can solve it with the linearity of expectation also.
Very nice, very nice. I was going to tell you that only. I haven't introduced the linearity of expectation. This is basically linearity of expectation. If I'm writing expectation of alpha x, the constant can be that constant can come out. And here, actually, it's simply only, it's not expectation, linearity of expectation. Here, this was just an overview. This is just because we are summing it over x. That is why it is coming out. It is just the sum here. What is this?
Expectation of px.
Expectation of x plus b. Basically, I can write it as if if I have y is equal to ax plus b, I can write expectation of y simply as a into expectation of x plus b. Linearity, or we can say we have proved like this. Same thing, just multiplying the sum with the probabilities and opening it. Is it fine?
Yes, ma'am.
Now the variance. Let us see what is the variance. Like we saw that ax plus b is this by the linearity, or we also saw the proof here as well. Now what about the variance? Let us see. We saw that variance is equal to x minus expectation of x square. So let's write that only. Minus expectation of ax plus b square summation of x. Let's open the square. Ax plus b. Okay, before opening, let's open these brackets. Linearity of expectation says expectation of b is b itself. Constant is constant itself. This and this cancelled out. Can I bring a square outside? Now I have x minus expectation of x. I have missed. I'll again go through it. What is the expectation? What we are doing is variance. Variance is basically, I'll go through it, expectation of x minus expectation of x square. I can write expectation as sum multiplied by probability, and x minus expectation of x whole square. Fine, this x and this is expectation of x. Sum into probability is expectation itself. Fine till this point? Or should I repeat? I think it's not fine. Again, I'll go through it. What I have written is variance of x. We know that it is equal to expectation of x minus expectation of x whole square. Okay, this we know. Now, what I'm given is y is equal to ax plus b. And now I have to calculate the variance of y. I can write it as variance of the expectation of ax plus b minus expectation of ax plus b whole square. Is it fine till now?
Yes, ma'am.
Now, expectation, I can write it as sum into the probability ax plus b minus expectation of ax plus b whole square into p of x. Fine. Sum into probability written. Now, opening the expectation here, by linearity of expectation, I can write a outside and expectation of x. Expectation of b is b itself. Constant is constant itself. This and this cancel out. A can we bring outside because summation of x only we have. A square basically. Wait a second. Because it's square here. Now what is this? Is it clear, or in any step any doubt is there?
No, ma'am.
Now what is this? This last thing, summation x minus expectation.
Ma'am,
Yes, yes.
where did P of x come from, ma'am? You already eliminated it.
Where P came from? That is what you are asking.
Yes, ma'am, in the above the field, right, ma'am?
P basically I can say that what is expectation formula? I am summing it, sum multiplied by probability. So instead of expectation, I have written sum multiplied by probability.
Okay, ma'am.
Okay, na? So now what is this? Can I say this itself is variance? See the variance formula? I can write it as expectation of x minus expectation, square, I missed it. Expectation of x square, this sum into probability I can write it as, and we know that this is variance and we can write it as variance of x. Any doubt from how we have gone from this step or any step? Summation multiplied by probability, we know that it is expectation, and expectation of x minus expectation of x squared, we call it as variance. So I can say that if I have variance is y is equal to ax plus b, is basically x. If I talk about its variance, a square variance of x we are getting. Any doubt in this?
No, ma'am.
So this is a actually why I did this basically like this. These are the standard formulas exactly used when I say variance is equal to this. We'll get some notation like this. We'll rather than derivating it, as soon as we see this, we'll say okay, variance is equal to a square variance of x. That is why I show how we are coming up with this. This is a very standard formula being used. And the other formula of variance which is used is, let us go through that. So I can write it as x square I'll open it 2x expectation of x plus expectation of x square. Just opening this. What we usually, this is the variance only. Opening the square, a square minus 2ab plus b square into probability of x. Writing like this. Opening the brackets, summation of x square, probability of x minus 2 expectation of x, summation of x, x p of x plus expectation of x square, summation of x, p of x. Just opening it, brackets. Now, we can write it as expectation of x square into probability of x minus 2 into, this is also expectation of x only, summation of x into px, expectation of x square whole square, x, summation of x, p of x sums up to 1. So expectation of x square, and then we come up with minus 2 plus 1, that is minus 1. This is basically, I'll again go through this, don't worry. Formula of variance, which is widely used, which we'll use for our Bernoulli binomial distribution as well. So expectation of x square, this is basically called as second movement. When we call it as second movement, when x power, this is basically movement. And if 2 is written second movement, 3 is written third movement, expectation of that minus expectation of x whole square. This is the formula. And this is how we have derived it. Just nothing we have done. We have only opened up the brackets here. And just by opening up the brackets, x square plus 2x minus 2 expectation of x plus expectation of x square. Then opening with the p of x, we'll get this. Basically, I want to tell you about this formula. This is also widely used here, the variance formula.
Ma'am, can you show the last step?
Yes.
Yes, ma'am.
Nothing I have done. I have just opened the bracket, x square minus 2 expectation, then p of x, summing it over x, then again summing it over x here, and then x square, this is called as expectation of x square, basically. This 2 expectation of, sorry for the disturbance. And then we came up with this formula. Wait a second. My screen is visible.
Yes, sir.
Yes, ma'am.
So we'll use this formula directly, basically the variance. Maybe, okay, after this lecture, I'll share the, I was thinking to make a Slack group from so many days. Okay, I'll make a, like last 5 minutes, we'll make a Slack group, or any one of you can make it. And then I'll share all the document, like the lecture notes there, as well as I'll also upload this video also. And still you have any doubt, we can also talk on the Slack or on the mail ID. Now coming to the different types of random variables. First of all, coming to discrete random variable. Most easiest one, Bernoulli random variable. Can someone tell me about it? Come on.
Same event for a multiple n times.
Yes, yes. You are not audible clearly. Can you?
Same event occurring for multiple times.
Same event occurring multiple times. Same event. Can you give an example?
Coin toss for 100 times.
Okay. Is it Bernoulli or binomial?
It's binomial.
You are getting confused. Bernoulli is we have either this or that. Coin
Either
tossing
it
one.
happens or not.
Yes.
Either it happens or it doesn't.
Or not. We'll come to your answer also in binomial distribution. Either it happens or it doesn't happen. Before heading to that, I'll ask you simple, I'll give you, before going to Bernoulli random variable, just we saw Bernoulli random variable is either an event will happen or either that event will not happen. Now, suppose, consider an email marketing campaign. Very simple, where email has 10% of chance of being opened by receiver. So if opening of an email is considered as successful and not opening as failure, what is the probability of, okay, and what is the probability of failure? Very simple. Yes? Point. This is basically what is Bernoulli. Either the event will happen, either the event will not happen. So suppose the probability mass function I'll compute. So if the event is happening, so basically P of x is equal to 1, which means that there is a success. Then I can say that this is the event that is 10% of time that is happening. So and the event is not happening, that is basically x is equal to 0, or I can say x is the random variable, basically either it is 1 or either it is 0. So if it is 1, basically I can say the email is opened, or if it is not 1, or suppose coin tossing only. Either the head appear or either the, if head appear, I take the x is equal to 1. Either if the head doesn't appear, then I'm taking it as 0 basically. Two events are there, either that will happen or either that will not happen. That is what it is shown in this example here. Any doubts?
No.
What is the mean? What is the expectation?
Then P.
Basically it is P. If I say that, okay, I want to show you something. How it is P?
Because random variable have only two values, 0 or 1. That's why.
So if it is suppose 1 and I'm taking it as 1, if x is equal to 0 or 0, so basically I'll get that P here. I'll explain it. If suppose my probability x is equal to 1 for my heads and it is P there, basically So that is what I have written. Either the probability is 1, either the probability is 0 here. So probability of x is equal to 1 for the 1, that is p, and for 0 it is multiplied by 0. So 1 minus p basically, but it is multiplied by 0. So we get it p here. Now can you tell me the variance? We know that variance is equal to x square minus expectation of x whole square. As we have done it. What is expectation of x square? Can I say here? Again p. Wait a second. 1 square into p plus 0 expectation of x square into 1 minus p, that is p. And we know that expectation of x is p. So p square. Can I say this is the variance?
Yes, ma'am.
1 square, x is x square into p. X was 1 square into p plus 0 into 1 minus p. Again, I got the expectation of x square as p. Now I have the expectation of x square as p and expectation of x as p itself. So p square. So I can say p into 1 minus p. Is it clear? Should I proceed?
Yes.
Now comes binomial random variable. Can you tell now?
When a coin is tossed 100 times or a event occurs repeatedly, we have to find the probability of a certain event.
Yes.
Ma'am, Bernoulli ma'am trials is repeated several times.
Yes, very good. So basically, as one of you said that the event is repeated basically, or I can say Bernoulli events when we are repeating it number of times, that itself is binomial. Is this statement correct?
Yes, ma'am.
If we are repeating the Bernoulli events only. So this is basically, I can say px is equal to r, or this is pd like PMF. What I have written, can someone tell me? I wrote the formula like of PMF. Can someone tell me? NCR p raised to power r. Yes.
N represents the number of time events occurs,
Hmm.
or is the number of permutations, and N is the remaining number of permutations to calculate the probability.
So if I say that r times head appear out of n times, can I say that the combination of that then NCR p raised to power how many times? What is the probability and how many times? And Q means q raised to power n minus r, how many times the head is not appearing, that probability. Is it fine to say that? What is the expectation?
And
Yes, NP, yes, correct. So I can say that as you also told me that it is the sum of Bernoulli random variable itself. Let these be Bernoulli random variable. And I can write it as like this also. What is each of them? Probability, the expectation P, as we saw here, that this is P only. The expectation of Bernoulli random variable is P only, and how many times they are? N times they are, like these are basically N times. So can I come through this NP? Is it correct to say?
Yes, ma'am.
Similarly, if I say the variance of X, I can say that variance is equal to X1 plus X2. These are also Bernoulli, and we know what is the variance? P into 1 minus P. So P into 1 minus P plus P into 1 minus, sorry, P into 1 minus P. And this is also repeated n times. So can I say, oh sorry, P into 1 minus P, not P divided by 1 minus P. I'm speaking P into and P into 1 minus P plus P into 1 minus P.
Ma'am.
NP 1 minus P.
Ma'am.
Yes.
Variance also follow linear.
Yes. I can write variance of X1 plus variance of X2. But if there is a constant with it, then it will be square outside. Like if I say that expectation is there, then the expectation come outside as it is. Na? Like if I say that I have this, this expectation of AX, then we simply write it as A expectation of X. Na? But in variance, it's like A square variance of X. That is what we have done. Is it fine?
Yes, ma'am.
So now we did the binomial random variable as well. Now coming to geometric. Now can you tell me about geometric random variable? Come on. By coin tossing only?
Ma'am, we repeat the event till we succeed.
You're not audible clearly. What you're saying, if you repeat the event, then?
Till we succeed.
Yes, absolutely correct. Repeat the event till we succeed. Or toss a coin till we get a head, if head is successful. If tail we consider it successful, toss a coin, repeat the event, toss. Which means tossing a coin is an event, suppose. And I'll write what you have said. Repeat the event till we succeed. Or I can say head is success. Considered as success, getting head. So toss a coin until you get first, until you get first head. So what is its probability mass function? Can I say 1 minus P is unsuccessful and P is basically getting success. 1 minus P probability of getting not getting success, and suppose I want to say that what is the probability, I'll write, of X is equal to K. Can I say K minus 1 times I didn't get success and then I got the success? I'll repeat the event until I get the P. So if X is equal to K, K minus 1 times I failed and then P is basically the success. Is it correct?
Yes, ma'am.
Now coming to...
Ma'am, what is that factor, ma'am?
You're asking about this?
Yes, ma'am.
This is probability mass function. How much how we calculate the probability of this? How we calculate the probability of a random variable for discrete random variable. Then we call it probability mass function. For suppose geometric random variable, how I'll calculate the probability. How I'll calculate, that is what I'm trying. And calculate the probability, like what is the probability of getting the failure, k minus 1 times. If I suppose 10th time I get the success, then 9 times I get the failure, I can say, and then the 10th time I get the success, basically. What I 0.5 is, okay, I'll give you an example for PMF means only the probability here, I want to say. Can someone give me the better explanation for that also?
It is a function of probability. To replace the function of probability.
Function of probability for the discrete random variable, basically. Function which is giving the probability, basically. That discrete random variable, this is discrete random variables we are talking about. Basically, they are exact. What is the value of that? What is the value when what is the probability of that, I can say. So this is just a term which we are using in context of discrete probability to find out discrete probability, nothing else. Got it?
Yes, ma'am. Thank you.
So now, suppose okay, I'll come to the examples afterwards once I'll go through that. Okay, now coming to the expectation. Now, what is the expectation of x if the x is basically a geometric random variable? Come on.
1 by p.
1 by p, exactly. Can I say that? Okay, wait a second. So, any intuition how it is 1 by p? You got what was okay? I'll go through very though it was told in class as well, but okay, I'll go through very easy. I'll go through first of all very easy derivation, and then if it's if you think that okay with the class you want to go, then it's fine. Or I'll try to make it more easier. Suppose okay. I want to say that with if I tried something, what it is basically, I want to get a success, and we'll have the number of trials until we get the success. That is what we are trying to say. Suppose I say that I'll get the success x1 is x is equal to 1 at the first try only. What I mean to say, first try is successful. And the other thing I take is A2, an event where I don't first try is failure. Can I say this? So what I mean to say, suppose x is equal to 1, the first try was successful. First try is failure, so I'll end up with the second try, third try, or so on. If first try is success, which means x is equal to 1, first event. Given the first event, what is the expected value of x? That is 1. First of all, tell me whether it's clear or not. Or explain me if it's clear, and say if it's not clear, then I'll again go through it. If first try is successful.
We get succeed in the first trial only, that's why expected value is.
So if x is equal to 1, given x is equal to 1 first try, what is the value of x? Expected value of x is equal to 1, which means I am succeeding in first try only. I don't want to, I am getting the, if success means getting ahead, I am getting ahead in the first try only. Expected value of getting the head is equal to 1, given the first try only. Now, if I fail in first try, Then I'll go for the successive tries. X is greater than 1 means second try, third try, or fourth try. I can say it will be equal to 1. First try, I have to do 1 plus expectation of X. 1 plus the expected tries of X. Now, if I say expected X, I can say probability of X is equal to 1 in the first try, or I'm adding it up both the events. That is how we get the expectation. Probability, basically, the event of this when we are getting the first try only and more than one try. Suppose this is basically I'm getting in the first try, that is P here. 1 minus P, I'm not getting in the first try. And what is its expectation? 1 plus expectation of X. So expectation of X, I'll say P plus 1 plus expectation of X minus P expectation of X. P expectation of X is equal to 1. Expectation of X is equal to 1 by. Is it clear? I'm thinking I'm only speaking.
No, ma'am, it's clear.
You can see others also.
Ma'am, I have doubt. Ma'am,
Yes.
could you explain where you got P plus 1 minus P into 1 plus E expectation of X before the cancelling step, ma'am?
This one. This one. Huh?
Yes, ma'am.
So we have, basically I'm saying that if I get, we have two things. Either X is equal to 1, either X is greater than 1, which means I'll get in first. So I'm saying that if I get in first, this is basically equal to 1, I know. If I'll get in first only, then I don't have to do anything. Then basically it is X is equal to 1, I am saying P. This I am saying is 1 by P, 1 minus P. And if it is greater than, X is greater than 1, then I have to do 1 plus this expectation of X. That is how I get it.
Okay, ma'am.
Any other doubts? Can you try to do variance on your own? First of all, I'll give you some time. If it's just 2-3 minutes, try it. Then I'll by the formula or something. Try at least. I want that you should also try to do something. Try at least. Yes. Okay, let's do it. Anyone has tried? All of
Ma'am,
you
is 1 by p square correct, ma'am?
1 by p square. No, something. Okay, let's try. Then you can find what was wrong, and you can tell me also. What is variance? Expected x square minus expectation of x whole square. We saw this formula. Let's try to find this first. I can first of all say, okay, expected x square. Similarly, as we have calculated this, p into 1 plus 1 minus p, or I think, first of all, I'll go through this. It's more of exhaustive. Similarly, if I say that x is equal to 1 is given, then what is x? Suppose the first try is like 1, as we have taken that in this also, first try is successful. Let us take similarly as that also. Now, the second also, let us take it as that x is greater than 1. Can someone tell me how? Okay, I'll leave this variance to you only. I'll remember this. I'll make a, I'll give you just hint that you have to, like, I have separated these. X is equal to 1, x is greater than 1. Similarly, you have to calculate expected x square, expected x whole square, and then subtract it. Try to do it. Let us make it as homework problem. The next thing, in the next class, like one of you can share your screen and explain to the whole class how this variance you are calculating. Is it fine? Let's make this two-way, like I am only not doing this, so that you can also learn lot of things, because self-practice is most important. I've given you just that hint that though you know this, you have to solve through this. And again, you have to take these two conditions and try to solve it. Should we proceed forward? Yes. Yes. Should we proceed? Am I audible?
Yes, ma'am.
Hmm.
Yes, ma'am.
So let us take it as homework. Is it fine for you guys?
Okay, ma'am.
So next class, I'll expect one of you can explain in the class by sharing the screen itself. So discrete random variables and negative binomial, I'll not discuss. It's the same, only just the opposite of that. Maybe in the next class, next class, I'm thinking we'll try to solve these mixed questions of Bernoulli, binomial, geometric, and then continuous as well. And then you have to find out that which distribution you have to apply, and we'll get more intuitive understanding. Here we are only doing the proofs and all, so we can get more intuitive understanding about those. I think it will be beneficial for you. Is it fine?
Okay, ma'am.
So continuous random variable. So can you tell me first of all difference between discrete random variable and continuous?
Discrete are countable and these are not.
Can you speak loudly?
Ma'am, discrete are countable and continuous are not.
Yes, absolutely correct. So we can count the discrete, and for continuous, it's basically not possible to count here. Basically, they are uncountable values. And so what we do for these uncountable values, can we say
Ma'am,
some
we can integrate
interval? Or, yes,
and we can integrate.
integrate. What is integration? Why we do what? Okay, so leaving these apart, what is integration? Why we do integration?
And
What is
summing
the
up very small values.
yes?
Ma'am, it's equivalent to summing up very small, infinity small values.
Yes, kind of. Like we can say, can I say sum of very small value, or I can say accumulation of all the quantities, sum of all the quantities, or when we talk about integration, we talk about what is the area under this graph, basically, or what like volume is given, what is this, what if the interval is given, what is the area under that interval, what is the accumulation of the quantities if suppose this interval is given a and b, then how many number of what are the total accumulation of the quantities which are lying between a and b, then we calculate this integration. That is the intuition behind integration. Am I correct? Or as you say that sum of all the values. What
Yes,
is
ma'am, it covers the
differentiation?
whole range.
Yes. What is differentiation?
I'm dividing a value into very small parts.
Though we'll not go to that, the rate of the change and all those things. Let's stick to this only. So here, like in the last, we were saying probability mass function. What we call it here, probability density function. Is it correct? So
Yes, ma'am.
that is what I mean to say. That if it lies, so we say that okay. And area under the graph, if I say minus infinity to infinity, that is equal to 1. So we interpret that they're infinitely small, so they can be close to this value. And with this representation, if I say expectation, so this is summing only in the sum in suppose what is it discrete I say the expectation. If I talk about discrete random variable, what I did is I sum it over all the values, basically. That is what I'm doing is p into basically x into that is what I'm doing. So here also the same thing is done. Instead of sum, I'm using integration just because these are continuous. You got the difference? Why we are using integration? Just they are continuous.
Yes, ma'am.
So instead of sum, we are using the integration, and the same formula of the expectation is there. Don't worry, I'll go through these all distributions, these random variables again by having the examples in the next class. Exponential random variable. So can someone tell me what is exponential random variable? What is the PDF of that?
I
Ma'am, can you
mean,
define?
cases like how many possibilities are in failure, like uh, n letters are dispatched, like how many n letters are not reached to their address.
Yes, yes, yes. Absolutely. Can I say the PDF of it is lambda e raised to minus lambda x
Yes, ma'am.
if x is greater than 0 and 0 if x is equal to 0. Basically, we have this memoryless property both in exponential and geometric distribution. This is basically only, I can say, continuous form of that. And though we'll go through this, is Poisson process also covered in the coming classes?
Yes, some Poisson is covered.
So we'll go through the Poisson process, then we'll again come to this exponential distribution and everything. So coming to this, if I talk about this only 0 to lambda. Okay, I have this graph. Can I say this is exponentially decaying? That is why this name is exponential random variable. They exponentially fall, and this lambda is the rate parameter here. Maybe these words are like what I'm saying or something, but slowly we'll build up. Don't worry about that. Calculating is its expectation. Integrating it, basically, minus e lambda x. This minus comes out when we integrate 0 to infinity, and then 1. And now calculating it. Though I'll show you all of these things. First of all, try to get the intuition behind that. What is, okay, leave this. I will cover in the next class what is the mean, what is the variance of these as well. Okay, these I'll show you in the next class. I'll just go through this. If I talk about symmetric, then we come to Gaussian distribution. I'll just go through the upper layer now today of the continuous random variable. Next class, we'll go through in the detail and the expectation of the Gaussian or normal variable. First of all, the PMF is basically this. Again, it's symmetric basically. And this is 1 over root 2 pi. I think it's for so that integration should be sum up to 1. That is why we are writing this 1 over root 2 pi. And this is basically the Gaussian random variable. How it came, we'll discuss in the next class, and the expectation of x is equal to 0. So both of these we'll discuss in detail in the next class, how Gaussian random variable and exponential random variable came. I'll just give you a glimpse of that. One more thing, central limit theorem. I'll just give you the glimpse of that. When we have so many independent random variables, IID way. Can someone first of all tell me what are IID? Independent and identical distribution. What is independent? What is independent?
Their probability is independent of each other.
Can you again speak loud? Can you be loud?
When their probability is independent of each other, and
one of
they are distributed, and they are distributed uniformly over the range.
I can say
it can be used in cases like customer standing in a queue, and which customer will get served last or something.
Okay, customer standing in queue. What others think about this example?
Repeat the example, please.
He's saying customer standing in the queue is IID. How can we say that?
Yes, ma'am. If they are uniformly distributed, then we can say that.
Yes. Independent, can I say that if I say about customer standing in the queue, the customer arrival, or I can say the service, is independent of the others. One customer is arriving, the other customer is getting service. They are independent of others. They are not getting affected by the others. The outcome of any random variable does not affect the other random variable. That is basically independent. Identically distributed, which means that either they are having the same distribution, any distribution they can have, Bernoulli, binomial, anything, but they should be same. They are same. Independent, identical means same distribution they are having, and independent means they are independent of each other. It doesn't affect of like whether one customer is coming and to the other customer, basically. That is what it is called as IID nature. When we take a lot of IIDs basically drawn from any distribution, then we say that they converge to a standard normal distribution, that is Gaussian distribution. When we take a large number of IID random variables, they converge to a random Gaussian distribution. We'll discuss in the coming classes how basically it is converging to Gaussian distribution. We'll discuss more about exponential random variable and Gaussian random variable as well. And we'll also discuss the examples, more of the questions of that. Now, I think as I got the mail also from the students that they want the assignments as the last half an hour is left. So can we solve the questions of the assignments? Is it fine?
Yes, ma'am.
So we'll take 5 minutes of break and then I'll come back and we'll solve the questions of the assignment 1 and 2. So 6:30 we'll meet again. Is it fine?
Yes, ma'am.
Yes.
So can we start the class again? Everyone is there?
Yes, ma'am. Yes, ma'am.
So is my screen visible?
Yes, ma'am.
Can everyone can open the assignment 1 and we'll try to solve it. First question, if 9 coins fall to the floor, what is the probability? Okay. 9 coins fall to floor. What is the probability of 4 heads and 4 tails and 5 tails? This now I think I can expect it from you. You have already solved this assignment. So those who are having problems so others can know. Let's make it a discussion thing, like rather than I'm telling you the answers. Yes, come on. I'm not answering, asking the answer, how to solve it.
I'm using binomial theorem. Sorry. Binomial distribution.
Yes. Why binomial?
Yes, ma'am. Yes.
Why binomial?
Because we have repeated them several times. The event.
Yes, we are repeating the Bernoulli random variables. Can I say in the easy language?
Yes, ma'am.
And I think someone has written multinomial expansion. Yes, that also we can do it here. So as we have done this binomial distribution, so let's solve through that. So can I say 9C4? What is the probability of getting the head? 1 by 2, 4, 1 by 2 not getting the head. Is it fine? Or I have written incorrectly? Is this fine?
Yes, ma'am.
So what is the answer? I'll not solve. Can someone tell directly?
63 by 256.
63 by 256. Now, the second question. You guys got the second question or it was tough? Number is perfect if it is yes, yes.
No, ma'am, it was fine.
It was fine. Okay. Sum of all if its proper divisors. We roll three, I'll say dices. What is the probability that product of numbers that appear on three faces is perfect number? Now, as you have got it, please can you help me in solving it? What is perfect number? Can you tell me first?
which is equal to sum of its divisors except itself.
So which is equal to sum of its divisors. So what are the perfect numbers? Now can you tell me?
6 and 28.
6 and 28. How 6 is the perfect number? Yes.
1 plus 2 plus 3 is 6 itself.
So 1 plus 2 plus 3, I am getting 6. So that is why. And how 28? And 1 into 2 into 3. Okay, that. How 28?
1 plus 2.
1 plus? Am I correct?
Yes, ma'am.
Okay, so what are the divisors of 6 basically? 1, 2, 3 I can get. 1, 1, 6. 1 into 2 into 3 is 6 and 1 into 1 into 6 is 6. So how many permutations basically? Can I say 3 factorial? It can be 1, 2, 3. It can be 3, 2, 1. It can be 1, 3, 2. So 3 factorial. What about 1, 1, 6? What about 1, 1, 6?
That is 3. Then 3 factorial by 2 factorial, that is 3.
3 permutation because 1 is getting repeated. What about 28?
Number 7 is not in domain, I guess.
That's what I am
It's not
thinking.
possible.
It's not possible. So 28 cannot be formed. So I can say,
Yes,
can
from 20.
so can I say that 6 is only the possible? So I can say 3 plus 6. 3 permutations, 3 permutations here and 6 here. So 3 plus 6 is equal to 9. And total, how many can be formed? You got this first of all. 28 cannot be formed, as you are correct here. As we are having
Divided by 216.
6 power 3, I can say.
16.
So 9. Is it fine? Now the next question. A card is picked from 52 well shuffled. What is the probability of the card? This is easy one only. Red or club?
Ma'am?
Yes.
But the options in the second question were not right.
Okay, 9. What is the probability? Okay, what is the answer they have written?
They have not given 1 by 24.
Maybe by mistake or something they have written. I was actually taking this 28. Now only I realized when I solved this before the class only. So I was taking this 28 also. By taking this 28, I was getting like one Not 1 by 54 again. 1 by 12. We have done something wrong. Can someone help me? Yes, come on. What is 9 by 2? 6.
1 by 24.
1 by 24. Okay, 1 by 24 is not the option. Okay, I'll go through it again. Or maybe they have given the wrong answers as
They
well.
have given the wrong option.
That is what. Okay, let's go through the next. A card is picked from a pack of 52 well shuffled, red or club. So we know the formula. What is the probability of getting red?
26 by 52.
What is the probability of getting club?
13 by
1
52.
by
And what is the probability of getting red and club?
13 by 52.
Sure.
No, it's zero, I guess.
0.
Club is black in color, so we can't get red and club basically. So it's bit 39 by 52, which is 3 by 4. Fine.
yes, ma'am.
The other question is a deck of cards is shuffled. Okay, cards are shuffled and cards are drawn one at a time until a jack appears. Okay, if we draw another card, what is more likely than the next card is jack of hearts or it is ace of clubs? So, what do you think about this? If you are drawing one card at a time, what is the probability that will it depend or both are equally likely? Can we determine or can I say that both are equally likely that jack of hearts can also appear and then ace of clubs? Are they independent? Yes. What are your views? Yes, come on. Come on. Yes. Uh, Someone spoke. I think you're not audible. You're writing in the chat as
Ma'am, I have a doubt. Ma'am,
Yes.
ma'am, there is given a card of jack is taken, ma'am. A jack.
Hmm?
So, since there are only 4 jacks in the deck of card, there are only 3 jacks remaining. Should ace of card be more probable than jack?
What others think about this? Yes, one way we can think that, okay, one jack is taken. What others think about this? He said a valid statement only. If one jack is taken, then it should be like, see, the jack's probability might be less and then ace can be given the more chance. What are your others' views about this?
Uh, ma'am,
Hmm?
ma'am, we draw another card only if when we don't get any of the jack in the previous card we have drawn.
Yes, I can't hear you. Again, you can say.
Ma'am, we only draw another card.
Hmm?
We don't any of jack in the previous card we have taken out.
I am not getting what you are trying to say. Can you repeat? So
Ma'am, we
sorry.
only draw cards
Hmm?
until we get one jack. that implies that we don't have any of the jack till now.
A deck of cards is shuffled and cards are drawn one at a time until a jack appears. Okay. I also misunderstood. Okay, we have to shuffle a card and cards if we draw another card. We haven't taken any card till now. I was also thinking card jack is drawn. We haven't taken any card until now. We don't know that first card is jack. What is more likely? The next card is jack of heart. So can I say both are having, if one of them is taken, one jack has already been taken also. Still, both of them are having equal probability, 1 by 51, 1 by 51.
Ma'am, but we can't perform another card drawn if we have already taken a jack. Ma'am, the moment we get a jack, we stop the trial.
Yes, you are correct. Still, we'll go to question again. A deck of cards is shuffled and cards are drawn one at a time until a jack appears. Okay, you are correct. That like cards are drawn and one at a time until a jack appears. If we draw another card, what is the problem? What is more likely that the next card is jack of hearts or the ace of clubs? What do you think? Is it written that first card was jack or first card was not jack? I'm getting your point that once we get jack, then we can't get the other card. Is it given that jack is taken before only? Jack has already been drawn. So now if we draw another card, what is more likely than the next card is jack of heart or ace of clubs? Then it is same probability that jack will be taken or ace will be taken.
Ma'am, but I have a question.
Yes.
What if in the first it is mentioned that we are drawing another card? That is, we have drawn at least one card before. So, ma'am, if the first card is ace,
Okay.
Ma'am, then the number of ace gets lesser than the number of number of jack.
Yes, you are correct. Yes, you are correct. But they haven't given us actually. If they have given us that ace is taken, then I'll surely say that the number of ace is less. But yes, we can consider that also in this condition. Yeah, I'll think about this. We'll come to this again. That what is like. If I say that ace is not taken, then I'll say correctly that both of them are equally likely. If I say that ace is already taken, then I can say that jack of hearts. If jack of heart is already taken, then I'll say obviously the second round will not be taken.
Yes, ma'am.
We'll go through this question again maybe and try to find it. Like I'll go through it again. Okay.
So the correct answer should be we can't determine answer in this case, and we need more information about the ace one.
About the first one, maybe. Okay, I'm not sure because I'm thinking that we don't know about the first card. If I know about the first card, then I'm thinking like whether it should reduce or it should remain the same. But okay, I'll go through it. Whether it cannot be determined or both of them are equally likely, we'll discuss in the next lecture. Yes, your point is valid also that if first time the ace is taken, then the aces are less only in the numbers than ace of club. Okay, suppose if I take the ace, then is it like that ace probability will be less? Is it something like that? Okay, think intuitively. If I take in the first one ace, now I have 3 aces left. I have 4 jacks left. But what I want to take? Ace of club. Now what I want to take here? Jack of heart. I don't care about ace of heart, ace of... What was earlier before taking? What was earlier? 1 by 52? Can I say the probability of getting ace of club? What was earlier? The jack of heart, 1 by 52? Earlier, before first one. Can I say that?
Yes, ma'am.
Now, what is after that? After I have taken ace of heart. Suppose, as you are saying, I have taken ace of heart. Now, what is the probability? if the question was ace, not only ace of club, then I can agree. But if about ace of club only, then if I take ace of heart also, then also my probability is 1. It's not any ace I can take, then the probability will reduce. Are you getting my point? If the question was, what is the probability of getting ace? So from 4, I can get to 3 if the first time the ace was taken. But now the question is, what is the probability of ace of club? Earlier also it was 1 only, 1 ace is only present. And if I take ace of heart also, then also 1 ace of club is present and 1 jack of heart is present.
Ma'am, but what if the first card is ace of clubs?
What if ace of club? Then obviously it is they are okay. Then you are going to extreme case. If then they'll not ask this question. Then next card is jack of heart or ace of club. Then it doesn't it's like okay, ace of club is not present only. Then obviously they'll not ask. The question is a deck of cards. Basically, they are not assuming here. We don't have to go to that extreme. Yes, when that is 0, then I'll say okay, jack of hearts only. But we have to take that case that ace of club is also present, jack of heart is also present. Then what is more likely? Can you say now equal? If they both are present. Actually, I was also going through it. I was also thinking that if ace is taken, but then I went again, okay, now it's not ace, it's ace of club only. If I take ace of heart also in the first go, then it will not affect my ace of club. Are you getting? Then both of them are equally likely.
Yes.
What are others' views about this? What others think? Yes, come on. Yes. Come on. Am I audible? Is it clear or I should go it again? Go through it again?
Ma'am, it's clear.
Clear? Basically, it's like if both are present, jack of heart or ace of club, then I take first go ace also, then also ace of club is 1 by 52, again 1 by 51, both of them, then that is both equally likely. Now the next question is, suppose 3 people get sent their letters from post office in random order. Okay, 3 people are sending the letters from post office in random order. What is the probability? Probability that none of them gets correct letter. So if none of them gets correct letter, suppose I have A and A's letter is going to B, B's letter is going to C, C's letter is going to A, or A letter is going to C, C's letter is going to B, or B's letter is going to A. Is this only the combination I can get it wrongly delivered? What do you think? I'm solving like this only. Yes, we can solve through other. I'm solving simply like this. Okay, 2. And what are correctly I can say A is going to A, B is going to B, B's letter is going to B, and C's letter is going to C. So simply, or what do you think? Can someone tell me? Or I can say there can be the other cases also. A's letter is going to A, B's letter is going to C, C's letter is going to B. So here we can have basically 6 combinations. I can say 3 factorial combinations, which is 3 into 2, 6. And these 2 combinations are where they are getting, no one is getting the correct letter. So 2 by 6, that is 1 by 3. Is it correct? Is it correct? I think already it's 7 o'clock, going to be 7 o'clock. So we'll discuss assignment 2. And next time I'll try to give you more intuitive understanding behind this distribution. And mostly what will be my main motive is that I'll come up with the questions mixed with binomial, Bernoulli, geometric, exponential, and all those things, so that we can solve in first 40 minutes and then go to the next week lectures and all, like whatever they have solved, like done and completed in the next week. Is it fine? Any feedback which you want to give, so that we can go through that in the next week, or something you are not understanding? Yes.
Ma'am, I couldn't attend previous session, ma'am. Could I get the video link in YouTube?
Okay. Wait a second. I'll upload today the previous lectures videos also. So this is the YouTube channel name, Prableen Kukreja. So you can go through those previous. I think only one I have uploaded. Second and third today's one I'll upload it tonight or tomorrow morning.
Okay, ma'am. Thank you.
Okay. And if you guys have any doubt, though I got one mail also, I haven't replied till now. Maybe he's not present today. If you have any doubt. Is it fine? Thank you so much, class.